this tutorial. So in this tutorial I will show you how to join the Kaggle competition and then create a new Jupyter notebook in Kaggle with the given dataset, and how you can run codes in that notebook, and then after all how you can create your submission file and submit that file to the Kaggle competition. So let's get started. So first of all, you will be provided with a link to the competition using which you can join the competition. So here is a link, and this will take me to a demo competition that I have set up for demo purposes. So this is the demo competition. So as you can see in the top right corner, there is a button that says join competition. So if we click on this button, then there will be these terms and conditions that you will have to agree to in order to join the competition. So here you click I understand and accept, then you will be joining to the competition. So remember that the account that you are currently logged into in Kaggle will be used to join this competition when you follow this process. So here we can see the overview and data and then code and all the things that are in this competition. So first of all, there will be this data panel under which you can go and you can look at the dataset. So what is the type of files or folders in the dataset? Here you can get an overview of the dataset. So to get started working with this dataset in a Kaggle notebook, you will have to go to this code panel. So here in this code panel, you will see at the top right corner that there is a button called new notebook. So when you click on this new notebook button, you can see that a new notebook is created. So this is basically a Jupyter notebook running on Kaggle servers, and this notebook by default will have the competition dataset attached with it. So in the right side you can see that the dataset is already attached with this notebook, where I can find all the files that are in the dataset. So on the top left corner you can rename the notebook to whatever you want, and so this is a starting block of code that you can see, and just like a Jupyter notebook, you can use this Kaggle notebook and you can write codes in these blocks, and you can run these codes in this notebook. So for the purpose of giving a demo, I will not be writing the codes line by line. So here I will import a notebook from my own PC. Okay, so before getting started, I want to show you one thing, that on the top here you can see that this is a draft session. So on the right side you can change the session options. So here you get some options. So here in the session options, when you will log in from your own account and when you will verify your mobile number on your Kaggle account, you will get an option to upgrade to GPU from CPU. So you can use the GPU, that is a free GPU that is provided by Kaggle inside this notebook. So after importing this notebook, I want to show you something, that on the right side you have this option called session options. So here you can go and you can select if you want to run your code on CPU or free GPU provided by Kaggle. So if you select it to none, then this code will run on CPU only, and if you select other options from here, then you will get these GPU access freely provided from Kaggle. So for to get access to these GPUs, you will have to verify your mobile number in your Kaggle account. So that is one thing to be to keep in mind. So after selecting the session option to GPU, here on the top you can see this symbol. So when you click this, so your session will be started, and the dataset that is provided in the competition will be attached to this notebook eventually. So here you can see our session is running and we have access to GPUs here. So in the first block of code you can see there are some instructions about Kaggle notebooks. So I will give you a demo on some codes. So first of all, I want to explore the dataset, so I am importing some necessary libraries like pandas and numpys. These will be used to manipulate the data, and then there is matplotlib. We will use this library to plot the images and other data also, and seaborn also is a library which we can use to visualize data. So the second step, we want to load the dataset from our directory. So here we can see that we have provided the path to our dataset in these lines of codes. So where you can find these paths, so in the right side you can see that under competitions you have this dataset. So from the dataset, whatever file you want to have the path to, you can click this button on the right side, that is a copy button. So if you click this button, the path to this file will be copied, and you can paste this path to anywhere. So like this you can paste the path to the training files and test files, everything in this notebook. So after setting up the path to the data, we have so here if we run this, the libraries will be imported, and then if we run this block of code, then we can see that the data is getting loaded, and after loading the data we are printing the shape of the data. So the training data is of the shape 42,000 and 785. What this means is that there are 42,000 images or rows in this train.csv file, and each row has 785 columns. So first column has the information of the label of the image, and the rest of the 784 columns have the pixel values of the 28 by 28 images. So this is the shape of the data, and then these codes gives us some descriptive statistics about the data. So when we run this, we can see the first 5 rows of the training dataset. So here the first column gives us the label of the images, and the rest of the columns gives us the pixel values of the images. And then we are using this line of code to check if there is any missing value in the dataset. So as we can see, there is no missing value in the training dataset. Then we move forward to the distribution of labels. We can check the distribution of labels. So when we run this code, we can see how many images are there in each class. So there are 10 different classes, and on an average they have almost the same number of images in each class. So next step, we want to visualize some example images from the pixel values that are in this CSV file. So when we run this block of code, so after running this code, we can see some random images from the dataset. So the first one is 1, then 0, 1, 4, 0, etc., and the labels are also printed on top. So we are using these codes and to print these images. Then we move forward to the next step, which we can see the pixel intensity distribution. So here, if we run this block of code, then we can see this plot. So what this means is that all the images there are pixels with value 0 and pixels with value 1. So those are the two pixel values that has the higher number of occurrences in these images, and the other values of the pixels are negligible. Next up, we have an optional step. We can check for similarity among digits. So what it does is that it takes every image from each class, and in each pixel it puts the average pixel value from all the images. So here we can see the like the similarity among all the different images of the same digit. So this is it, and after that I will be skipping this SVM part, as this will be described later, and also this MLP part. So I will show you a CNN model that will be trained on this MNIST dataset. So first of all, we need the PyTorch library, from where we will be building the CNN network, and then we need the important functions from this PyTorch library. Then we are also importing pandas and numpy, so those are needed for the data manipulation. And then we are importing this transform function. So this will be used to transform the given dataset into our required format, so that we can use our CNN model to analyze these images. So here the first line of this line of code, that device is equal to torch.device. So this line checks if a GPU is available on our device. If a GPU is available, then this code will be run on the GPU, and if not, this code will be run on the CPU only. So if we run this code, so we will be running this code for 5 epochs. So while we are running this code, so we can see that this is a function MNIST dataset. So we are using this function to load our dataset and transform it to the required format. So here also we can see that we have set the path to our training dataset and test dataset, and then we have separated features and labels in these lines of codes, and then using transform function we are converting our pixel values to our required format to be fed into the CNN model. And then we are using here this MNIST dataset function that we have defined earlier to create the desirable format of training and test dataset to be run by the model. Then we are using these data loaders to load the dataset with we have set the batch size to be 64 for both training and testing dataset. Then here we are defining our CNN model. As we can see, we have a very simple CNN model. We have one convolutional layer, and then we have a max pooling layer, and then we have the second convolutional layer, and then we have again another max pooling layer, and then we have ReLU activation function and also some linear layers in between. So here so like this we have constructed a very simple CNN model. So using this function simple CNN to device, we are loading this model, and we are setting up our loss function as cross entropy loss in this line. And also for optimizer, we are using the Adam optimizer with learning rate 0.001. So we have run this model for 5 epochs. So this is the code to run the same exact model on the dataset for 5 epochs. And after running this model, we can see the respective loss in each epoch. So first epoch we have 0.2, then it goes down to 0.06, and all the way it goes down to 0.02, and after that the training is complete. So here we have also saved the model into our working directory. So in the right side you can see that there is one output section. So whatever we want to save, we can save into this directory. So this has we can also copy the path of this directory as similar to the dataset paths. So we have set the directory path here, so that we have saved the CNN model here. and after saving the model we can use this model. So first of all we are using this model to run on our test dataset so that we can infer the labels of the images from our test dataset, and we are saving these inferences to a CSV file where there is image ID and there is the predicted label, and we are saving this CSV file to our working directory. And also after saving the file we are using the same model to run on test dataset images. We select random images from the test dataset and we inference the model on it, and the predicted labels we have printed on the top. So here we can see that the model has performed very with high accuracy, and it has predicted all the given labels of the images. So after running this code, our model and our CSV file both are saved in this working directory, and then we can download any of these files that we have saved in this working directory. For example, I will download this CSV file, and now after running everything and completing our code, the most important part is how to submit our solution to this competition. So for that we will have to go back to our competition. So using this same link, if we go back to our competition, then we can see on the top right side that we have a button called submit prediction. So you can run your code on any platform. You just have to save your prediction CSV file, and you can submit this prediction file here, and it will be automatically evaluated for the accuracy of the file. So here I will browse the file and I will upload this CSV file. So it is in the given format, and this format is described in the overview of the competition. And after uploading, I will just submit the file, and as you can see, this file is being automatically evaluated, and it will take some time to get evaluated. And then we can see it is the evaluation is completed, and we have an accuracy score here which is 0.94. so this is a public accuracy score, and the private leaderboard score will be published after completion of the competition. So this is how you can join the competition. You can create a new notebook from the given dataset and then run your codes. You can save your files, and then you have to submit your file to the competition in order to get your evaluation done.
Hello everyone, I am Nikhil Jaiswal. I am a PhD scholar at Mehta Family School of Data Science, IIT Guwahati, and today I'll be demonstrating this Datathon. I hope my colleagues, some of my colleagues have given you some demonstration earlier, and I'll be continuing further. Okay, so today we will be doing multi-class classification using logistic regression and MLP models. So here is the code. So here the first cell we will download some important libraries. So I'll run this. So these libraries, these requirements are already satisfied. Now here from this link I'll download the data, and using this line it will unzip the data. So let's run this. So it is downloading the data from this location, and after that it is unzipping the folder, and after unzipping we have got these three files, sample submission, test CSV and trend CSV. Here you can see it on the left side. Okay. Now we will load the data using pd.readCSV. Okay. Okay, now we need to download some important libraries from sklearn, logistic regression, trend test split, accuracy score, and classification report, and import numpy as np and pandas as pd. We'll download these libraries that are necessary for our code. After that, using pd.readCSV, we will load this train CSV file, which is here on the left. So it ran. Now we will see what is there in this CSV file. We can see that using this trend.head, we can see that this file contains these labels 10140, which are the different digits in the image form, and these are the pixels of those images. So pixel starts from pixel 0 up to pixel 783 of different images, where each image contains one digit from 0 to 9. Okay. Now we will divide the data set into, so these are the labels and these are the pixels. So these pixels we will consider as the variable x, independent variable x, and this label is the dependent variable y, which we want to predict. So using this train.iloc, we can see that in the data frame, the x, the independent variables start from the first column. So this is the 0th column, this is the first column. So first column till last column we have the x variable, and the 0th column is the y variable. So here, that's why here it is 0. And after that we will do y.sType int, which will change the, if there were in the label column, if there were categorical variables, then this function, this sType method will change, would change those labels to integers. So this is what it is doing here. Now using this train test split function, which we imported here from sklearn.model selection, import train test split, we imported here. Now we are using it and giving it parameters x and y with test size 0.2, random state 42, and stratify y. Test size 0.2 means 20% will be used as the test set and 80% will be used as the trend set. So after that we'll get x train, x test, y trend, and y test. Okay, now we will run this. Okay, now it is running. Now after that we use the logistic regression model which we imported earlier. Since this is a multi-class classification, because we have to classify our data from 0 to 9. There are 10 labels from 0 to 9. So this becomes a multi-class classification model. That's why here we will use this multinomial parameter, and we are using this solver. Maximum iteration is 1000 and random state is 42. Okay. Now we will use model.fit, which will create the model using this x train and y train. So currently it is fitting the model. After that we will use this model.predict to on this x test, which we got from here. Okay, in this y pred we will get the predictions of the data in the x test, and after that we will use this accuracy score function and give this parameters y test and y pred. Y test we got from here, and y pred we got from here. This will give us the accuracy. After that we'll print the accuracy, and this classification report function which we imported here, classification report from sklearn.metrics library, Okay, so this classification report will give the report on the classification where y test is our predicted values and y test is the original values of all the images containing digits from 0 to 9 and y pred is our prediction. Okay, then we will print that report. So I ran that model, it is currently running. You can see this circle, this is showing that our model is currently fitting. You can see that this arrow is here, which is showing that our execution is at this step. Okay, so it will take a couple of minutes to run. So let's wait till it runs. Okay, so this was taking some time because it was working on CPU. Now I will change from here. I'll go from in the top. You can see here it is runtime, and in runtime you can see here it is change runtime type, and I'll click here on T4 GPU, which will use the GPU to run our model, so it will run much faster. Okay, now it is connecting to the GPU. Here you can see on the top right. It is connecting, and when it connects we'll run again, and this time it will run faster. Okay, we'll run all the cells again, the first cell, then the second cell. Okay, it is downloading the file from this location, then it is unzipping it. I'll run this cell to import all the libraries, then this cell to get the data, then this cell to see what is there in the data, then we will run this cell. Now it is again at model.fit. This time it will run faster because now we are using the GPU. Okay, here on the bottom left you can see it is showing how much time, so it is up, and now it is 18 seconds. So it will take around a minute or two to run completely. It's okay. So around 2 minutes it ran completely on the GPU, and here we can see the classification report. Here on the left we can see that different digits are there, 0, 1, 2 up to 9, and we can see the precision recall F1 score, which are the metrics, okay, to judge whether how good our model has performed. Our overall accuracy is 90%, 0.9, and these are the precision of individual digits. These are the recalls, and the F1 score, which is the harmonic mean of precision and recall. Okay, so the classification report appears to be very good. So we have created a good model to do multi-class classification on the digits. Okay, so now we had used the logistic regression model. Here you can see now, which is an ML model, machine learning model. Now we will use a deep learning model to do the same task. Okay, so for that we will again import some important libraries. From tensorflow.keras.models we'll import the sequential. Then from layers we'll import these dense and dropout, and this to categorical to convert the numerical to categorical values. Okay, again we got the x values from the train data, then y values, then we repeated the same thing again, y.sttype int to convert the categorical to integers. Okay, now also we need to specify that the labels, the total number of labels is 10 from 0 to 9. There are 10 labels are there. Again we are using the train test split to divide the data into the training set, x test, xtrain, xtest, ytrain and ytest. Again we are using this test size to be 0.2, which will divide the original data into 80% training data and 20% test data. Okay, now we are also here we are using a standard scaler which will like normalize the data, xtrain and xtest. It will normalize, it will first fit and transform on the xtrain, and then it will transform the xtest also. Okay, now here is our deep learning model. Okay, so the first layer is this input which is taken from xtrain.shape 1. Okay, this is the first layer. The second layer contains 128 neurons with activation value function. After that we have a dropout layer 0.3, which means it will drop the 30% of the neurons. Then the next hidden layer contains 64 neurons with activation again value. Then after that another dropout layer. Okay, after that in the last layer we are using the softmax activation function, because since this is a multi-class classification problem, so that's why we are using the softmax function. Also there are 10 classes, so here we are giving the parameter 10. Okay, we will run this model. Okay, model.compile, we are using the optimizer Adam loss as this categorical cross entropy. So in multi-class classification, the loss that we use is categorical cross entropy. We are using accuracy metrics as accuracy to judge how well the model has performed. Then we will use this model.fit to fit it on xtrain and ytrain, and the validation data that we are using is xtest and ytest. We are using 20, we are giving running it for 20 epochs, and batch size is 32. Okay, after that we will use this model. Here we fit that model, and now here we are evaluating that model on using xtest and ytest, which will give the test loss and test accuracy. Okay, after that we will use this model.predict to predict it on xtest, and which will give the predictions, and these are the actual values which we got from the ytest. We'll convert it using np, that is the numpy module. Okay, so currently it is, you can see that the cursor is here, that means it is fitting the model. We can see that there are 20, we gave here the parameter 20 epochs. Okay, so it has RAM. Okay, So in the epoch 1 we can see that accuracy is this, loss is this, validation accuracy is this, validation loss is this. In the next epoch only the accuracy increased from 76% to 91%, then it increased to 92, 93, 94, and then the last in the 20th epoch the accuracy was around 97.30 and the validation test accuracy was 96.52%. Okay, so we have fitted the model. Okay, now we will get the classification report. We'll run this cell. Here we got the classification report. So the precision of 0 is 98%, its recall is also 98%, F1 score, the harmonic mean of precision recall is also 98%. We can see that for all the digits 0 up to 9 the precision is above 96, and for all the and the recall of everyone is 93 and above, at least 93. Okay, so here we can see that this deep learning model performed better than this logistic regression model. Okay, so in a similar way you can run your you can run the task or the test that you are given on your data set. Okay, so this is it.